Okay, next is question number 14. Okay, so here the question says a student clamped a meter rule so that it was vertical. Okay, she dropped a ball from rest near the top of the meter rule as shown. Okay, so basically the student is investigating using a free fall method. So that's pretty much similar to core practical 1 of unit 1. Okay, a strobe emits flashes flashes of light. The time interval between the flashes is constant. Okay, the time interval between the flashes, it is what? Constant. Okay, the student photographed the following ball using strobe lighting. The ball can be seen at different heights in the photograph as shown. So this is a figure, this is a photo basically for what? For the free falling ball. Yeah, free falling ball uh, using a strobe light. Okay, for each flash of light the student determined the distance fallen by the what? Ball. Okay, part A is saying she took one photograph using a strobe app on a mobile phone. She took a second photograph using a laboratory strobe. Okay, the time interval between flashes was the same for the strobe app and for the laboratory strobe. Okay, each each flash of light from the laboratory strobe has a smaller duration than each flash from the mobile phone. Okay, so basically the duration of strobe from laboratory, it's less than the duration of lightning from the mobile phone. Okay, explain how the smaller duration of each flash from the laboratory strobe affected the uncertainty in the measurement of the distance fallen. Okay, how it will affect the uncertainty. So if the duration of flashlight it is of smaller, length. Okay, then what does it mean? It means that within that small time, within that smaller duration of flash, okay, the ball will fall a smaller distance. So if it falls smaller distance, and since the time is smaller, so we can have more frames or more pictures or more uh, photographs. Okay, so if you have more photographs, then we can combine them accurately to get a more clear value for the distance, fallen distance. Okay, so for 2 marks you need to explain. You don't need to say everything here. For 2 marks we will say here what the first point is. uh, Within smaller duration of flash, the ball will fall smaller smaller distance, right? Okay, so since flash time is smaller, so more frames. Frames, it means basically a smaller interval of photographs. Okay, more frames could be found. Okay, flash time, since flash time is smaller, so more frames could be found. So distance fallen can be what? Measured more accurately. Okay, can be measured more what? Accurately. So what? Uncertainty how it will affect it, right? So we can say uncertainty will be smaller. That's it. So that's what we can say for part A of question number 14. Fine. Okay. Next is part B. In part B, it says the student recorded the distances as fallen by the ball and corresponding values of the time t. So part 1, it is asking to explain why a graph of s against t squared gives a straight line. Okay, so this is pretty simple question. Look, s against t squared. So compare using this equation. S equals to what? Ut plus half of what? At squared, right? So what we can write? S equals to half of at squared. So they said what? S against t squared. So u is 0 because it has been what? Released from rest. Okay, so if you consider, so comparing with y equals to what? Mx equation, what we can say? The gradient. This is y, this is x, this is on the y-axis, s on the y-axis, t squared on the x-axis equation. So gradient equals to what? Half of a, right? So acceleration is in this case what? It is gravity, right? G, which is constant, so since the gradient is constant, so constant gradient means what? Straight line, right? Hence straight what? Line. That's it. That's what part B1 has asked for. Fine. Okay, next is part B2. So here the question says the student plotted a graph of s against t squared as shown. So here you go, you can see a displacement to time squared graph. So here they are asking to determine the acceleration of free fall g using the student's graph. Okay, so we should use this graph to find the acceleration of free fall, that is g. We need to find out the value for g using this graph. Okay, so definitely we know that the gradient of the acceleration time graph, sorry, not the acceleration time graph, it is displacement to time squared graph, it is what? Half of g, right? So this gradient we need to find out considering a suitable point. So let's say which one we can consider perfect. We can consider this point. Look, this is exactly at 0.02 and its displacement it is what? 0.1. Okay, so this gradient it's what? Y2 minus y1, which is 0.10 minus 0 over x2 minus x1, so 0.02 minus 0. So half of g, it would be 0.1 over 0.02, that gives 5. So the value for g would be 10 meter per second squared. Okay, so you might get confused here why we got 10 meter per second square, why don't we get 9.8 here? No problem, they will accept range of values here. So 10, if you get 10 meter per second square, if you get 9.9, if you get 10.1, still it's fine. Okay, but not 11 or not 12, it should be within a limited range, an acceptable range. Okay, so 10 meter per second square, this is fine, no problem. Okay, it will be accepted. 10 meter per second squared. Okay, so this is the what? Value for acceleration of free fall that we found from the student's plotted graph. That's the End of question number 14. Fine.